In the last video, we learned how lift is generated by a difference in pressure above and below the wings of an aircraft. Today, we're going to tackle another way that lift is generated. What if I told you planes stay in the sky by pushing air down? This phenomenon follows Newton's third law of motion, which states that every action force has an equal and opposite reaction force. Before we get started, let's review some vocabulary. This shape is called an airfoil and is the cross-section of an airplane wing. The leading edge is the forward part of the wing, the trailing edge is the back of the wing, and the chord line is a straight line connecting those 2 points. This line is used to measure the angle of attack, an important concept in today's video. Okay, back to Newton's third law. The bottom of the wing is bouncing airflow down, changing its velocity, which is a change in momentum, and any change in momentum is accompanied by a force. Because you have a force pushing the air down, then the air must have a reaction force pushing up, resulting in lift. Now, you might be confused how the bottom of the wing is bouncing airflow down, when in all of my diagrams thus far, the bottom of the wing has been horizontal. This is more accurate. To understand how lift is generated, we first need to learn about the angle of attack. It's important to note that the wing's chord line is not usually parallel to the aircraft's longitudinal axis, or the fuselage, which is the main body of the plane and where passengers sit on commercial aircraft. During the aircraft's design, an angle of incidence is calculated, and this remains constant during flight. As the pilot maneuvers the aircraft, the pitch can be adjusted. This is motion about the lateral axis, which points the nose up or down by changing the tail of the aircraft. The pitch is adjusted by the pilot during flight to control the altitude of the plane. Changing the pitch is what alters the angle of attack and the amount of lift generated from the wings. The angle of attack is the angle between the wing's chord line and the relative wind, the airflow. Remember, the chord line is drawn from the leading edge to the trailing edge. So, if the front of the wing is upward, then the relative wind will come in contact with the bottom of the wing and bounce off downward. The wing produces a downward force on the air molecules, changing the velocity of this fluid. Velocity is a vector quantity, so a change in magnitude or direction means a change in velocity. Since P equals mv, a change in velocity is a change in momentum. Any change in momentum is accompanied by a force. Due to action and reaction, the air generates an opposing upward force on the wing, generating lift. Now let's talk about flaps. The moving panels you've probably seen on the back edge of the wing when you're sitting near it on a commercial flight. Flaps extend downward from the trailing edge of the wing, and their main job is to temporarily change the wing's shape. By lowering the flaps, the pilot increases both the camber, the curve of the wing, and the effective angle of attack without actually tilting the whole plane. What does that mean for lift? Well, 2 things happen. First, the wing pushes more air downward, increasing the upward reaction force. In addition, the airflow above the wing has to speed up even more to follow the steeper curve, which reduces pressure on top of the wing. This concept is explained more in the first video on lift. Both of these effects add up to a big boost in lift. This is especially important during takeoff and landing, when planes are flying slower and need extra lift to stay in the air. But there's a trade-off. Lowering the flaps also creates more drag, which slows the plane down. Pilots actually use this drag during landing to help control speed and keep the aircraft stable on approach. So in short, flaps are like temporary modifications to the wing, helping the plane take off at slower speeds and land safely by striking a balance between more lift and more drag. Whether or not flaps are used to alter the effective angle of attack, airplane wings are constantly pushing air down to generate lift.